Hello everyone, myself Deepa Singh, working as assistant professor in Gyan Vihar School of Pharmacy, SGVU Jaipur. Today we discuss about next topic of this industrial pharmacy. Previous lecture we already covered the capsule or regarding the complete information of capsule, including soft gelatin, hard gelatin capsule, different excipient used in a capsule formulation, or the different example of these excipients, including evaluation method, manufacturing method, and how you formulate this capsule, including soft and hard gelatin capsule. So in today's lecture, we discuss about the pellets, and it's the next topic of this industrial pharmacy subject. And in this pellet, we include or covered introduction part of the pellet, including definition and the description of the pellet. And next is the formulation of the pellet, how we formulate this pellets and different excipient that you use for formulation of the pellet, or procedure for formulation of the pellet, and pelletization process means how this process takes place. So all these topic of pellet we study in this lecture or today's lecture. This is a topic of industrial pharmacy one subject, fifth semester BPharm. Before starting this topic or before starting this pellet, we should know about these object or basic learning objects of this topic. In this objective, first is a brief introduction about the palette, means a complete or descriptive introduction about the palette. What is a palette, or the dosage form, or how you formulate, and the parameters or different route of these palettes, or how you use, means complete description of the palette or about the palette. Next is a formulation required for the palette, means which parameter or which formulation is required for the palette, or different excipients that are used for formulation of this palette. And next is a pelletization process, means there's a chances that different process are involved for this manufacturing of a palette or formulation of the palette. So in this, you should know about these process or this pelletization process. So these are the learning object. Now, introduction part of the palette or definition of this palette. In this, pelletization can be defined as an agglomeration. Means if you see these palette, then it is an agglomerate shape or agglomerate of some particles or small particles, and size enlargement process that convert into fine particle or property of a bulk drug and excipient into a small free flowing or more or less spherical unit called as a palette. Means these pellets are mainly spherical in size, and it is formed with the help of agglomerate. Or if you know that what is a pellet, then you easily identify that this type of formulation. So this is a mainly enlarged process, or taking more time to formulate the pellets, or there may be some problem or error is also observed when you formulate these pellets, because it's not easily formed. There's some trained or experienced person is required to maintain the spherical shape. Otherwise, it form irregular shape, or not an even shape, or circular shape, or spherical in shape. And in this size enlargement process that convert the fine particle or powder to bulk drug and excipient into the small. And if your formulation has a large particle or bulk particle, then it's converted into small particle or fine particles. And these particles are free flowing in nature, or more or less spherical. It means it's a free flowing as well as a spherical in nature, and uniform spherical in nature. That's why it having a good free flowing property, because they are spherical in nature, easily free flowing in nature. And so this type of formulation is known as a pellet. And the pelletization involves the manufacturing of agglomerates with narrow size range, usually with mean size from 0.5 to 1.5 mm, named as a pellet. Means you can also say that it is agglomerate, or these pellets will have a very small in size, and it is almost 0.5 to 1.5 mm in size. So this small size particle is named as a pellet. Means there's so many advantages of this pellet, but it may take some time or difficulty to form the uniform spherical pellet. But it has a good flow property, uniform within the pipe, pellets or particles or agglomerate from small particles, or these pellets have a small diameter in size, normally 0.5 to 1.5 mm in diameter. And the pellet are free flowing property due to the uniform spherical in shape. So good flow property or free flowing property. So this is regarding the definition and introduction part of this pellet. Next is technological advantages. These pellets have a very more advantages or so many advantages regarding the technology because it is a good type formulation and less disadvantages or less drawback. So technologically, when we see the pellet, there's a different advantages. And this first advantages is improvement of uniformity of the content. It maintain or dosage form or not dosage form, but drug containing is maintained. Means your drug should be in a maintained form or improvement of the uniformity of a content. Your content also uniformly distributed or uniformly divided in your formulation or your content present uniformly in your palette. So it contains uniform content or uniformity in content. Next is prevention of a dust formation. It is a very good type of formulation. Dust formation is also prevented with the spherical shape or good spherical in shape, uniform shape. So it is also helps to prevent from a dust formation. And next is increasing bulk density and decreasing bulk volume. Means bulk density is increased because they are small in size or easily free flowing, but bulk volume is decreased. So this is also one good advantage. And next is define shape and weight improve the appearance of the product. Means there is a different shape and weight of this palette according to requirement. So you can also improve the shape and weight of this palette. And when you improve this shape and weight of the palette, it appearance the product or improve the product for appearance. Next, in this improvement of a handling property, when some handling property is also easy when we see the pallets because it's a handy in nature or easily handle everybody due to free flowing property or less place is required to store or handle this type of formulation of pallets. So improvement of handling property or improve handling property due to free flowing properties. It is a easily flowing nature. And next is improvement of the hardness and flammability of the pallet. It have a good hardness because it's formed by different process or by different machines, and there's a hardness also sufficient because it passes through different process. So rather than the flow property is good, it also have a good hardness and a good flammability of the pallet, and it do not easily break. It should have a sufficient strength to wear and tear, and they have a good hardness and flammability is also good of this pallet. It don't break easily. And next is control release application of the pallet due to ideal low surface area, the volume ratio that provide an ideal shape for application of a film coating. Means you can also coat these pallets or apply the coating material to these pallets because these are spherical in shape and good flammability. So you can coat these tablet or also called this tablet. So after coating, it have a good property or it improves the property. And this property is good for having a controlled release type formulation or drug is released in a controlled manner and slowly from your pallets due to low surface area, surface volume ratio, and it provide an ideal shape for the application of a film coating. Means it is also one important parameter for controlled release type formulation or release slowly in a controlled manner due to their identical in shape or their coating property or due to the good small size particle or large surface area. So you can also formulate control this type formulation with the help of these pallets. Next is therapeutic advantages. Previous one are the technological advantages. Now when we see the therapeutic advantages or according to effect of particular disease or as a medicament, it is also a very good as compared to other type of formulation. So in therapeutic advantages, pellet can disperse freely throughout an area of the GI tract due to the spherical in size or uniform in size or small particle size. It can easily distribute or goes in your stomach or in the GIT area, or it should good effect or good disintegration property due to easily dispersion of this pellet in GIT. Next is pellet reduce peak plasma fluctuation and minimize potential side effects. Means it is also helps to maintain the peak plasma concentration or less chances of fluctuation. Means improve the fluctuation also or reduce the fluctuation. Due to this, it also reduce the side effect or toxic effect or provide the maximum therapeutic or desired required effect. So this is also one advantage. Means due to this good property of palate, it reduce some fluctuation or reduce side effect and provide maximum therapeutic effect and avoiding the irritation effect of some drug on gastric mucosa. Some drugs show irritation or not compatible with the GI tract, and they show irritation and some side effect or toxic effect is also observed. But when we formulate the drug in the palate form for this GIT or GI tract, so in this condition, irritation is reduced or less irritation is observed of some drug, those who show the irritation. So you can also use those or also formulate the palette for those type of drug which show irritation or get irritated in a GI tract or GI mucosa. And next is modified release multiparticulate delivery system are less susceptible to dose dumping. If you are formulating modified release tablet or multiparticulate delivery system, means in single tablet you just adding 2 to 3 dose. So in this condition, you can say that modified release multi-participant delivery is formed, or some drug who show dose dumping or dose error also are reduced, or less susceptibility to dose dumping means less error or less dose dumping are observed with the help of this palette. So therapeutically, it is also very good formulation or very good formulation for showing more maximum therapeutic effect. So these are the therapeutic advantages. And next is disadvantages of this palette. Every formulation has some disadvantages. So in this palette part also some disadvantages, but it shows more advantages when we compare disadvantages part. In disadvantages, first is often palette cannot be pressed into the tablet. Means when you formulate or convert into reconvert or change into a tablet or compress into a tablet, it is a difficult to use this palette form, so don't convert into tablet. And because they are too rigid, in this case palette have encapsulated into capsule. That's why we already see in capsule part, you can feel these capsules with pallets also. So their rigid property or their unique property after forming these pallets, you do not convert into a tablet or in a tablet type formulation, and you can feel these pallets in a capsule only, but you don't convert into tablet. So next is the production of a pallet is often an expensive process or require highly specialized equipment. This pallet process is not a single step process. It requires multiple step or multiple equipment, and these equipments are very costly or expensive. And due to multiple process, it also have more cost compared to other formulation of tablet capsule. So this pelletization process is expensive or costly when compared with other formulation, and it have a lengthy procedure, require many steps to formulate, as well as equipment is also expensive, as well as trained person or specialized person is required to handle these equipment. Nobody handle these equipments, and if anybody is performing this pallet formulation or manufacturing of these pallet or pallets on specific equipment or machine, then there may be chances that uniform or spherical pallet is not formed. They have an uneven shape or uniformity problem is also observed. So for formulation of this pallet, a specialized person or trained person is also required. Next, in this control of the production process is difficult. Production control is also difficult, and the amount of water to be added is critical for the quality of a pellet. Overweighting can occur very easily. These pellets contain a specific amount of moisture or water content, so it is very difficult to maintain this moisture content or water concentration. It is also requires some specific concentration of trained person who have experience regarding the water content or moisture content. If you add more amount of water or more moisture, so in this condition, due to this high moisture or more moisture content, there may be chances that it overweight or show some wettability problem. And due to this wettability, there may be chances that it have a stability problem or it's not stable in particular temperature and pressure, or it can easily degrade. So this moisture as well as water content is also a difficult process to maintain according to the suitability or requirement. don't add more water. If you add it, then it will show overweighting of the pellets. So these are the disadvantages. Next is characterization of the pellet. Means which parameter will you require to maintain or how you form uniform or good quality pellet. So these are the characterization or step that you take precaution during formulation of pellet, and your pellet should be in according to this character of this nature. It should be in an even form or uniformly distributed contained or drug, and free flowing in nature, and all are in spherical form or in an uneven form. So these are some characterization of this pellet. Pellet size distribution means all pellet have a uniform size distribution, distributed in a uniform in size. And the next is the pellet shape. It should be a spherical in shape. If you are formulating spherical in shape, then your complete batch of pellet are in a spherical in shape and uniform in size. It don't show any uneven shape or improper size distribution. Some are small in size, some are large in size, or their shape is also uneven. Some are spherical or oval shape or any other uneven shape. So during manufacturing of this pellet, you should make sure that your pellet is good size distribution or good shape, and as well as surface morphology is also the same for all pellet or similar to all pellet, and you should also check the morphology of that particular pellet. Next is a specific surface area. Surface area is also same. All pellets have a small surface area. If there's a small surface area, it is really free flowing, or due to this specific small surface area. Not a small surface area, small particle size and large surface area. It easily free flowing and disintegrate or release in a good manner. So your all tablet have a good surface area or uniform surface area. Next is fragility. Fragility is nothing but the one parameter. In this, you should assure that the wear and tear property of their hardness. You should do not break easily or have sufficient strength during storage or until the expiry date. So all your pellets have sufficient fragility. It do not break or should have a wear and tear property is also good. And in this next is disintegration time. Disintegration time means breaking of this pellet into small particle or fine particle. When you are taking this pellet, then it breaking down into a small particle similar to a tablet. When you're taking the tablet, it again break in a small particle or like disintegrate. So in the pellets, it is also similar to a tablet. When you're taking a tablet, it can easily disintegrate or break when you come in contact with your body fluid or particular pH condition. So all pellet have a good disintegration time or easily get disintegrate according to requirement or particular time period. I don't show any problem during disintegration. Next is the dissolution. After this disintegration, dissolution takes place. Means the releasing of a drug from that particular solvent or that particular buffer. This also in a good amount or a good percent of release to this dissolution. And dissolution mainly we calculate percent drug release or how much percent of release through these pellets. So after this disintegration, dissolution is also in uniform form or in a good quantity and release maximum amount of a drug through this pellet. And next is the porosity. So it have a porous in nature, and then porosity is also uniform all pellet. So it can easily release the drug through this porosity. Tensile strength is also same for their hardness or their sufficient strength, how much it maybe can take to easily get break or have a strong in maybe storage or transportation. So this is the tensile strength. These are the method of pelletization, how we manufacture or formulate this pellet. So there's a different method of this pelletization or pelletization process. In pelletization, there's a 4 methods that are majorly used, and these 4 methods are further divided in subcategory. Now we discuss one by one. In this first method is agitation, and agitation in this mainly volume method we consider in agitation part. Next is compaction. In compaction, it is further divided into 2 parts. One is compression, and second is extrusion and spheronization. So this is the second method, and third is a layering method. In this layering method, it is again divided into 2 methods. It is for powder, and second is solution and suspension type of the formulation. And next is globalization or globulation. In this, this globulation is further divided into 2 parts, that is spray drying and spray congealing. So these are the four major methods of this palletization, and this is further divided into subcategory: agitation, compaction, and layering, and glucation. These are the four major methods or techniques for this palletization. Next, in this first method is agitation or walling. We already see this in this flow chart. Agitation, in this we include walling method. In walling method, it is known as spherical agglomeration, in which method particles are converted to spherical pellets by continuous rolling or doubling blender using a rotating drum or pan. Now, this method is limited. Name itself say that there's one process which is similar to a walling, means it continuously moving or rolling takes place. So this method is mainly for formation of the spherical agglomerate or spherical pellets, and in this method particles are converted to spherical pellets with the help of some equipment, some technique. In this, mainly rolling and dumpling blender are used, and these rolling and dumpling blender are continuously rotating with the help of drum and pan. Due to this presence of this drum and pan or continuous rolling and dumpling, your pellets get formed, and it's spherical in size due to this boiling process. And but these agitation or walling method have a certain limitation. You don't use this method for all type of the formulation. It have a certain limitation for some drug or some formulation. In this limitation, there's two types. One is liquid induced agglomeration and melt induced agglomeration. These are also two types for this walling and agitation method, or this agitation is divided into these two parts or two types. Next is a layering technique. It is the second technique for this pellet formation. We see in this layering, this one, and in this further divided to powder and suspension or solution. Layering process are the most well-controlled and straightforward pelletization technique. The layering process comprises the deposition of successive layer of a drug entity from the solution, suspension, or dry powder on the nuclei, which may be crystal or granules of the same material or insert starting seed. Means in name you easily understand that the layering process means multiple layer is applied, or you form the palette with the help of this layer process. You continuously apply the multiple layer or form the palette with the help of solution, suspension, or in a dry powder. You apply the layer on the nuclei and or maybe on crystals or granules of the same material in a started seed. And in layering process, most are a controlled straightforward pelletization technique. The layering process comprises the deposition of successive layer, means multiple layer drug entities from the solution. Multiple layer of the drug are formed, or you apply multiple layer onto this drug with the help of some solution, suspension, or dry powder of the nuclei. In this crystal or granules of the same material in a started are formed. And this layering technique is further divided into two parts or two types. One is solution suspension layering, and second is a powder layering. Means you form the layer on your drug, maybe in the form of solution suspension or maybe in the form of powder layer. So this is regarding the layering technique. In this layering technique, first is powder layering. In this powder layering, there may be some factors that are responsible to uneven pellet formation or improper pellet formation. If we see the factor affecting the process in this powder delivery rate, because powder is in dry in form, so there may be chances that it do not deliver good powder or in a uniform powder. So there's a powder delivery rate is also may vary or change show the problem in your pellet formation. Next is the flow characteristics of the powder. If your powder has some moisture or it's in a not a good form or proper particle form, so in this condition it also shows some problem or some flow property characteristics of problem in flowing. So these are the two problems or factors that are mainly affect your formulation. One is powder delivery rate, second is flow characteristics of the powder, and next is a fluid bed coating. In this fluid bed coating, particles are fluidized and coating fluid sprayed on the dry. Fluidized bed coating, mainly you take or maybe apply the spray material or coating spray solution with the help of this fluidized bed. So particle are fluidized and coating fluid spray on the dry. Means you put your particle on this fluidized bed and apply the coating material or spray the coating material and on the dry material or dry formulation, and a small droplet and low velocity of the spray medium assure an even product formation. If this a spray pattern or a spray coating solution have a small droplet or a small droplet in nature, then in this condition it form good palette or good uniform palette, and it should also have a low velocity for good spraying or spray medium assure good product coating. And in different type of fluidized bed process include top spray coating, bottom spray coating, that is versatile coating, and tangential spray coating, and roller palette coating. These are the some techniques that were used for this fluidized bed coating according to your requirement, and all are related to this fluidized bed coating. You can also apply spray from the bottom or from the top. So this one is a top spray coating, means you apply this coating material from top part of this spray dryer, and in bottom coating you apply this material from bottom part of the sprayer, and buster coating also known as bottom coating. Next is tangential spray coating. In this roller pattern and palette coating is used for this fluidized bed coater. This is a layering technique. This is your starting material or germ which you coat or form into palette form. So this is a germ material, and you spray some spraying solution or some solution with that form the Paris, and these germ or starting material continuously rotate in fluidized bed or fluidized bed dryer. And due to this complete rotation or applying this spray, it forms the one layer, or this spraying droplet can attach to this germ starting material. And after continuous rotation or rolling, it form one layer of this droplet or spraying material. You can see this in this image. And these are the binder droplet, and that spray on the upper surface. And in this starting germ, it formed the one layer. After rolling or liquid bridge is formed, then drying and solidifying. You dry this particle that attach or maybe come contact with your germ that form the liquid bridge, and you dry or solidify this layer or this droplet, because you are applying multiple layer. If one layer is not completely dry, then there may be chances that another will get stick or your palette is not in a good quality. So before applying next step or next layer, you should dry or solidify this granules or this germ, and this form the solid bridge. After this formation of the solid bridge, this first layer is completed, or you can say that your palette have one layer, and then again you repeat this procedure or multiple droplet is applied onto this germ. After applying this multiple layer, it forms too many layer onto this germ material or starting material. This look like onion structure. You can see this structure. So this is a germ or starting material, and these are the multiple layer that is applied onto a starting material, and it forms the final palette. So this is the final palette after applying too many layers. And this is a starting material, and these are the binder droplet that you applying on your starting material. It contact with your starting material or droplet attached to a starting material from the first layer. And after completing this first layer, you apply again and again multiple layer, and it forms the onion structure or multiple layer structure. And this is a final palette which is spherical in shape or uniform in shape. So this is a layering technique. And next is extrusion and speronization. So this is the next technique, and this extrusion and speronization takes place, or you form the palette with the help of extrusion and speronization technique. And this extrusion and speronization is finally utilized in the formation of a sustained release and controlled release delivery system. Means suppose you are preparing a formulation for controlled release or sustained release from preparation or formulation, those who require small release or for long period of time. So in this condition, you prepare this palette or by the help of this extrusion and speronization technique for controlled release as well as sustained release type of the formulation. Next is the main object of this extrusion and speronization is to produce palette or spheroids of uniform size with high drug loading capacity. Means these technique also have a good technique for formation of the pallet, and with the help of this extrusion and spheronization, your pallet or spheroids form in a uniform size and good quality and high loading capacity. Means you load more drug in this pallets, which is you form with the help of this extrusion and spheronization technique. So this is also a development technique for pallet formation. These pallets have a more capacity load the drug, or uniform or pyramid size shape pallets are formed, and you load the drug with, in the pallet. And this is mainly used for control and sustain this type of the formulation. In this product feature, extrusion and sterilization, dust free when you formulate your pallet with the help of this extrusion and sterilization technique. It is a dust free and don't have any dust particle, high sphericity, more spherical particle are formed. You can see this in image. So with the help of this spherical extrusion and sterilization, high sphericity is maintained, or all pallet have a spherical in shape or in uniform spherical in shape. Next is free flowing due to the spherical in shape or uniform spherical in shape. It also show good flow property or easy flow property. Next is compact structure, smaller structure, and easily carried the structure or this pallet. And next is low hygroscopicity, means moisture containing capacity or moisture present capacity is also low in this type of the pallet. Next is high bulk density. Bulk density is also high, and low abrasion, narrow particle size distribution, and smooth surface. Due to the narrow particle size, it also have good rate or good parameter. And these extrusion and sterilization form their pallets also a smooth surface or even surface. So these are the some property or product feature of pallet that is prepared by extrusion and sterilization. Next technique is hot melt extrusion. This is another technique for formulation of the pallet. In hot melt extrusion is the process of converting raw material into product form of uniform shape and density by forcing it through a die under control condition. Means some condition you maintain or require some condition, and with the help of this melt extrusion or hot melt extrusion, you form the pallets. In this extrusion process, mainly converting raw material into product of uniform shape and density. Means these are the raw material or raw excipient that is you use for your formulation of a pallet. With the help of this raw material, you usually form the pallet. These pallets are uniform shape and density. You can apply force by the some pressure or some die under the control condition. So this is the raw material of crystalline drug. And this you apply some polymer at specific condition at a specified temperature. Means you take the drug in a crystalline form, or after taking crystalline drug, you apply some polymer at a specific temperature, because it's such that it's a hot melt extrusion technique. And after this particular temperature, it gets melt, and from the hot melt extrusion or in a solution form of hot melt extrusion. And after this solid solution extrude, this is a hot melt extrusion, and again at particular temperature it solidify and form the solid extrusion. After solid solution extrusion, you form the tablet or your pallets. This is a hot melt extrusion. And this hot melt extrusion, the theoretical approach to understanding the melt extrusion process is therefore generally presented by dividing the process into 4 sections. These are the 4 category of 4 sections that you divide according to hot melt extrusion. Fitting of the extrusion and conveying of the mass, means how much material you feel or feed in your extruder or in your this feeding of extrusion is also very important parameter, or how much volume you feed in this extrusion. Next is conveying of a mass, means how much mass is conveying or transfer from one to another part. And next is the flow through the die. After conveying this mass, speed or flowing property of this extrusion material is also very important. And next is exit from a die and downstream process. After completing this process, your pellet get exist out from the die parts, and in this downstream process takes place. And this is regarding the hot melt extrusion. This is a apparatus or equipment that is used for hot melt extrusion. In this fitting, this is one is a hopper. And this will fill your drug as well as your polymer or any other excipients. So this is the filling or hopper that contain the polymer as well as your API or drug and polymer. And after feeding or through this hopper, it passes through this chamber or this equipment. And here melting this takes place at particular temperature because you maintaining temperature of this container. And after a particular temperature, it gets melt. And after melting, the polymer and your API get mixed. Means this is a hopper. You're adding suppose drug, and this one is your API, and it come in this container. And after coming in this at particular temperature, it get melt. And due to melting, it can easily mix in this container. The next step after melting, mixing is takes place, and homogeneous discharge means after mixing the polymer and API get mixed and homogeneous solution is formed. And in next step, this homogeneous solution get discharged, homogeneous discharging is takes place. And next after discharging, cooling is takes place because this is maybe semi-solid or liquid in form at high temperature. Or here is the cooling is takes place, or you change or replace the temperature of your pellets due to this cooling process or changing the temperature, the pellet gets formed or solidified particle is formed. So this is the process of hot melt extrusion. In this application in pharmaceutical industry, the melt extrusion has been used for various purposes such as improving the dissolution rate and viability of the drug by forming solid dispersion and solid solution. Means if you are preparing a pellet and you require good quality of a dissolution and viability of a drug or your pellet. So in this condition, for improving viability and dissolution rate, or for more viability and dissolution rate, you can form the hot melt extrusion technique helps to improve the dissolution viability and show the more viability and dissolution rate. And next is controlling or modifying the release of the drug. Means if you are control type of formulation or modified type of the formulation you form, then in this condition you can also use this hot melt extrusion technique. And next, masking the bitter taste of the active drug. If your drug is not in a good taste or in a very bad in taste, or some spell in there in your API or drug, so in this condition you can also improve the taste and odor of your drug with the help of this hot melt extrusion technique. Next is a granulation technique. In this, we already discussed that different granulation technique in tablet part. In this, you can also use fat granulation technique for spherical pellet formation. The process of adding liquid solution to powder involves the masking of mix of a dry primary powder using a granulating fluid, and fluid contains a solvent that must be volatile and meet all the physical requirement of the compression of the tablet. Means you can apply the volatile solvent or some solvent which is used for this granule formation, and it has to form the spherical pellets. And next is fluid bed granulation. In the process of carried out by continuously in a fluid bed granulator and a spraying of a granulation solution onto the suspended particle. Means with the help of this fluid bed or with the help of this granulation technique, you continuously spray the solution from the different layer. With the help of this spraying, the particle are from uniform granular in size or from the pellet because they are suspended in the air, and continuously spraying solution is applied into this particle. And after applying, it can dry in a hot air stream. This is a diagram of fluidized bed granulator. You putting your material or granules or particles here and applying continuously spray, and it can suspend it in the air, or with the help of this air it can dry easily. This is outlet airflow, and this is the filter bags, and here's a granulator spray nozzle, and this is the fluid bed, and this last part is the HEPA air or inlet of the flow. This is a fluid bed granulation, and in this fluid bed granulation, the fluid granulating is perforated by following steps. One is a tangential spray method. In this spray blending of the formulation powder, including the active ingredient, filler, disintegrated, free flowing of the air, and granulation of the mixture by spraying a suitable liquid binder onto the fluidized suspended powder bed and drying of this granulating product to desired moisture. Means you use different excipient or pre-blending which takes place in this fluidized bed granulation, and use some filler, disintegrant or other excipient, and continuous airflow is also takes place, and due to this airflow you granules are dry and they are suspended in the air and it can easily dry, and desired moisture content is removed and sufficient which is suitable for your formulation is present in the granules or your palette. It's a moisture content. Next is a parameter. In this equipment parameter, product parameter, process parameter, we should maintain or check properly time to time. Advantages over traditional wet granulation: automated perforated 1 unit and saving a cost, transfer losses of a time. Means it is take less time or cost also save, or fast process or automated process. Today's wet granulation process improve the dissolution efficacy of both nifedipine and spironolactone tablet. It's an example of two types of tablet, nifedipine and spironolactone. Let's form this tablet with the help of this good wet granulation. It is in good quality. Next is a melt granulation. In this granulation is achieved by traditional of metable binder. It is a solid state at room temperature, at melted temperature ranges 50 to 80 degrees Celsius. This one is the example PG, and this is a grade. And melted binder that act as a binding liquid, and no need for drying phase, since drying granulation are often by cooling is room temperature. This is a spray drying. In this solution of suspension is sprayed without excipient into hot air stream. Generally dry and highly spherical particles takes place. This is a filter or heater, and feed liquid is from here, an atomizer, and this one is a drying chamber, and it's a product collector or exhaust. The tube is going, and this is a dry product. So this is a spray drying equipment. And next is a spray congealing. It's also spray chilling. Congealing means chilling or cooling of your equipment. This is also known as a spray chilling, and technique similar to spray drying, but a source of it is required. Means this is a similar to a spray drying process, but in spray drying we're using heat, and in this congealing using cold condition or chilling condition, and drug can suspended in the molten wax and gives a sustained release effect. Means your drug release slowly with the help of this spray congealing. And monoglyceride similar component are spray or conjugate. This is a diagram, and in large scale or industrial level, this is another plant, and cold air is applied. This is a cooling chamber and filling, and product from this side and here, and the powder or air out or cyclone product is this one. Cryopelletization is the next technique. In this cryopelletization process, where liquid droplet out of the formulation converted into liquid spherical pellet by using liquid nitrogen gas in the fixed medium, that is 160 degrees Celsius. Means in this cryopelletization, nitrogen gas is required and temperature remains at least 160 degrees Celsius. And these are the application. It is used to intermediate holding step. It is used for long-term storage. It is enabled to ultra-fast freeze drying, and this is used to fermentation reaction. Other than this, some other advantages was this technique. It is very easy to handle. It produces free-flowing pellets. It offers ultra-fast flowing for consistent and fast reconstituent, eliminating the need to freeze in the block, which is difficult to handle. This is a diagram, liquid feed and atomizing gas, and this is a lane, and this is a solution powder. So this is all regarding the pellets, including introduction, process, how we form different types of technique for pelletization. So after completing this topic, you should know about brief introduction about the pellet, including description and introduction, different formulation required for the pellet and pelletization process, or different technique that is used for pellet formation. Next is the reference part. In this reference, first is the Ansel pharmaceutical dosage from the delivery system, 8th edition by Lois V. Alan Nicholas, G. Popovich, Howard C. Ansel, published by Vihar Publications Equity Limited. Next is a textbook of physical pharmaceutics by CVS Subramaniam, published by Bella Prakashan. Next is a theory and practice of industrial pharmacy by Leon and Lackman, Happert, Lieberman, Joseph King, 3rd edition, published by Bagger's Publishing House. Next is a Martin Physical Pharmacy and Pharmaceutics, 5th edition by Patrick J. Simple, published by Lippercott, William and Wilkin. So these are the reference regarding this topic of pelletization. Now, after reference, we cover the question related to this topic. In this first question, which of the following material used to in extrusion: A, wax, B, granules, C is powder, D is a pellet. And in second question, extrusion process, extra shearing occur in which part of the system? A, feed section, B is pumping section, C is collapsible section, and D is a transition section. Next, in the third question, melting section is another name for which section? A is a feed section, B is a transition section, and C1 is a pumping section, and D is a collapsible section. And in next or fourth question, how are the extruded material cooled? In this, A option is water. There is a contact with cheese surface, and C is the air, and there is the oil. So this question you answer easily because you already study different techniques or temperature condition or some pellet formation condition. And next in this fifth question, which of the following is not important factor for cooling extrusion? A is the reduction in shrinkage, B is the reduction in dissolution, C is the easy of adding color, and the next is the rate of the cooling. So these are related to factors or some factor that affect the cooling of the extrusion rate. Next and sixth question, which of the following is not application of a polymer extrusion? Means if you are using some polymer in your extrusion technique or pellet formation. So in this you can select any one correct application of this polymer extrusion. In this option is door in solution C, B is a chewing gum, C is a cable, and D is circuit board. These are the four options for this sixth question. Next and seventh question, non-pharmaceutical additive. A option is a formulation ingredient must be highest watt or lowest watt. B is the watt parameter is the most common for all injectable products. C is a process in which you can produce product that loves the dry state. And D is a since large volume of fluid is administered, what do it want contain? Next in eighth question, Carr's index determine. You can also calculate Pallas Carr's index, and this A option is a particle size. B is a powder flow. C is the thickness of the tablet, and these are all mentioned as all ABC options are correct. Next in ninth question, in opacent extensor, which type of a powder used in the coating solution formulation? A is a fine inorganic powder. B is a fine organic powder. C is a both fine inorganic and organic powder. These depend on the formulator or choice of the formulator. And in last 10th question, for microcrystalline cellulose, also known as it's a one polymer, you can use this for pellet formulation as a binder or for different coating purpose. So you should know about the full form of this microcrystalline cellulose. So in A option is the HPMC, B is CMC, and C is PVC, and D is FVC. HPM is hydroxypropyl methyl cellulose, CMC is carboxymethyl cellulose, PVC is polyvinyl cellulose. So next is FVC. These are the four options. You can select any one correct option regarding this microcrystalline cellulose or another name of the microcrystalline cellulose. So these are the questions related to this topic or this chapter, including palette of different techniques used for the palette formation or process of the palette formation, including different procedure or the sub techniques. So after completing this lecture, you can easily answer this question. This is related to this topic or lecture. So thank you so much for watching and listening to this video. Thank you everyone.